All right, hello class. I'm going to record section 8.4, multiplication and division with real numbers. And this is for your Math 410 course, all right? And so in your workbook, this begins on page 41 of your 410 workbook, okay? Not your co-rec workbook, but the 410. And we're gonna start by going over some of the rules that we have here. And I usually refer these to like rule number 4, this idea of multiplying and dividing with real numbers, and it's usually taken 2 at a time. Taken 2 numbers at a time. All right. Okay. So the first thing they say is that the product of 2 positive numbers is going to equal a positive. So they have generically A times B equals positive AB. And you don't have to write the positive. If you just write AB, it's understood to be positive. And product does mean to multiply. So you do want to learn that new vocabulary word. Product does mean to multiply, okay? Also, the product of 2 negative numbers is going to equal a positive. So they have negative A times negative B is equal to a positive AB. So again, you don't have to write the positive. If you write it as just AB, that's understood to be positive. So you don't have to put the plus sign in front of it. The product of a positive number and a negative number is going to equal a negative. So they have A times negative B is equal to negative AB. Okay, or they could also have it written, the negative A could be negative, or, negative A times B is going to still equal a negative AB. So the negative could be on the second number, or the negative can be on the first number, but they're different signs. So you're going to end up with a negative result. Okay, and so to generalize that, here's another way of saying that. In other words, we'll say that if the signs are the same, like over here, if the signs are the same, the answer is going to be positive. And then I'm also going to say if the signs are different, the answer is negative. So like here, if the signs are different, or here the signs are different, then the answer is negative. Okay. And then they have another rule here, is that the product of 0 and any number is going to equal 0. Okay, so yeah, any number times 0 equals 0. So they have some results here. A times 0, negative A times 0. And notice how negative A times 0, notice how they don't say it's negative 0. 0 is neutral. 0 is neither positive nor negative. It's just a neutral number, okay? So anything times 0 is 0, okay? Okay, then they go into some division with real numbers. It says for real numbers A and B, and then also X, where B is not equal to 0. So you see here, A divided by B, they're saying that the denominator cannot be 0. Yeah, because otherwise otherwise, if you let the denominator be 0, otherwise you get undefined. In math, we can't divide by 0. So you want to stay away. That's why you want to stay away from that. And note B cannot be 0 because otherwise it's undefined. And they say that A over B is equal to X, which also means that B times A. So I don't know if you can see that little raised dot there. That means B times X equals A. But they don't show you any work for that. So what they're doing is they're doing a cross product, and you've seen your teacher do a cross product before. When we're comparing fractions, is the first fraction less than, greater than, or equal to the second fraction. So one way to show your work is to do cross products. And so I can show you that here. A over B is equal to X over 1. Okay, and then we do these cross products. So you would first, in this order, the order is important. You'd have to start off with this A times 1, which is A. Okay, then you bring the equal sign down, and let me change my ink. And now you cross products, do the other product. X times B. X times B X times B is equal to XB. Okay, so basically this is saying the same thing. It's just here they have equals A last. Here we have A equals first. And BX is going to be the same product as XB. Okay, it's the same result. It's just a little bit out of order, but that's okay. It's commutative. Multiplication is commutative. And that's okay. You still get the same result. So they don't show the work, but that's true what they're saying. Okay, now here it says for real numbers A and B, again, where B you don't want B to be 0 because otherwise it's undefined. They say A divided by 0 is undefined. Okay, but they say the other way, 0 divided by B is equal to 0. So these are two important results that you don't want to get mixed up. Okay, and so what's happening here, because you want to be able to set these up using long division, the numerator, the top number, goes inside the house. So A divided by 0 is this, A, and then divided by 0. And there's something wrong with this. This is your divisor. And you know, divisors must be like natural numbers. Okay, and natural numbers are like 1, 2, 3, and so on and so on. Unfortunately, they cannot start with a whole number 0. They cannot, divisors cannot start with 0, and divisors cannot be decimals. They cannot be decimals. That's why if you do have a decimal, what teachers do is they fix it, they move the decimal over. And what they do out here to the outside when they move the decimal over is they also do that to the inside, and they move the decimal over the same amount of places that's needed. Okay, and then also divisors cannot be 0. They've got to be at least 1 or larger, and a counting number. Okay, so here, you know, when you try to say how many zeros go into the number, how many zeros go into A, they call that undefined. And that answer that you get is called undefined. Undefined. So I wrote this word here, undefined. And that answer that you get is called a quotient. That's your quotient. The answer you get after you divide is called a quotient. Okay. Now this A is called a dividend. Just so you learn your vocabulary, this is a divisor. This is a divisor. This is a dividend, and this answer is called a quotient. Okay. And then a cute way of remembering it. is, well, if you had an actual problem, like this is generic, but if I had like 7, let's say I had 7 divided by 0. Okay, that would be undefined. And the 7 would go inside the house. Well, on the calculator, what it says, it doesn't say the word undefined, but it still says something helpful. If I do 7 divided by 0, see how it has divide by 0 error? So it doesn't actually say undefined, but it still gives you something that's helpful. And it says divide by 0 error. That's enough to tell you that that's the one that's undefined. Another quick way of remembering that is like, what does it spell? And it spells no, like no, you cannot do this division problem, because the A, like we talked about, the 7 will represent N for a number, and then the 0 will represent the letter O, and that will spell out no. So that would spell out N-O for the number, and then 0, that spells out no. So no, you cannot do this division problem. That's the one that's undefined. But this one you can. 0 divided by B. So when you set this up, 0 divided by B, the 0 goes inside the house. And so when you say, and this just has to be a natural number, but when you say how many B's go into 0, because how many B's go into 0? So let's see, you've got, like, let's say you have all these marbles and you want to break them up into groups. You're dividing, you want to break up into groups. So like, okay, how many groups can I create? I've got all these marbles. So how many groups of, like, like 7, how many groups of 7 can I create? Well, you won't be able to create any groups, only because you have 0 marbles. And so when you say how many B's go into that, that would have to be 0, because you don't have any marbles. Okay, so B times 0 is 0, and 0 minus 0 is 0, and that's your remainder is 0. But this is allowed, and the answer is 0 for that. Okay, so the way this is spelled out, this would be spelled on. If I do, see, where can I write it? If I do, let me see if I can write it over here. If I do 0 divided by 7 on the calculator, let's see what the calculator shows you. 0 divided by 7, see, is equal to 0. Okay. And that spells on, like right on, like, yeah, you can do that division problem. That one gives you the 0, not the undefined. The 0 represents the letter O, and 7 represents the number, so N for the number, and that spells on. That one spells on, so that one gives you 0. So that's just a cute little memory mnemonic of no and on to kind of help you with that. But you are allowed to use calculators in the classroom, so as long as you know how to type it in correctly, you can also help get the answer correctly with that. Okay. All right. Other rules down here. It says that rules for division with real numbers, the quotient of 2 positive numbers is positive. And they have A divided by B is equal to positive A over B. And the quotient of 2 negative numbers is also positive. Negative A divided by negative B is equal to positive A over B. And again, they didn't have to write that plus there. They could have just written A over B. And quotient means to divide. So you want to learn that vocabulary word. Okay. And that's kind of why we have this here. See, quotient, saw that earlier. And then the quotient of a positive number and a negative number that's going to give you a negative result. Negative A divided by B is going to give you a negative A over B. And A divided by negative B, that's going to also give you a negative A over B. And so when I summarize these rules, I'm going to summarize these rules similarly to, and make it even shorter than the way I summarize these up here, because the rules are the same for multiplying and dividing two at a time. So here where I say, if the signs are the same, the answer is positive. So I can rewrite this here. These are the same, see, positive divided by positive. These are the same, see, negative divided by negative. So I can say that same signs produce positive results. Same signs produce positive results. Whereas if I summarize this in shorter words than this, if the signs are different, the answer is negative. Okay, so this I can summarize and say different signs produce negative results. Different signs produce negative results. Okay. So again, this is emphasizing rule number 4, emphasizing rule number 4. Okay. And then they have here average. The average or mean of a set of numbers is the value found by adding the numbers in the set and then dividing the sum by the number of numbers in the set. Okay, so let me see if I can increase that a little bit without just a little bit. Okay, so in section 8.3, we did a mean, we did a weighted mean in section 8.3. It was a weighted mean, but I think in that problem, in that recording, we had 10 students and you know, you had, 4 students got this grade, 1 student, I think, got a 91, this many students got this grade. So you had a total of 10 students. So what we did a weighted mean and we divided by the total amount. Well, that's very similar to this, except, this is just called a mean in general. You add them up and divide by how many you have. So there will be one problem in your workbook. I think there's a couple problems that in your workbook, but we'll do one in this section to review that. Again, it just won't be a weighted mean, okay, but it'd still be a mean. The other thing I need to say is that, let me decrease this. Going back to like your ideas of your rules, sometimes you're gonna have a need to multiply a lot of negative numbers or multiply a lot of positive numbers. So this is a good rule to have. They say, and you probably have heard this before, it says that if you have an even amount of negative signs, then their product is going to be positive. Okay, so you might be saying, what does she mean by even? Like, what's an even? So like even is like if you have 2 negative signs. If you have 2 negative signs, negative times negative, that's gonna be positive. If you have 4 negative signs, if you have 6 negative signs, if you have 8 negative signs, and then dot, dot, dot. So those are an example of even negative signs. If you're multiplying a whole bunch of numbers and you just count the negatives, and if they have an even amount, for sure the answer is going to be positive. So then you just then you just kind of, after you just determine the sign of the result, then you just kind of multiply like all the absolute values. You just multiply the numbers because you already took care of the sign ahead of time. Okay. Now, if you have an odd amount, if you have an odd amount of negative signs, if you have an odd amount of negative signs, then their product is going to be negative. So then you might be thinking, okay, what, give me some examples of odd. What were some examples of odd? Some examples of odd would be like if you have just one negative sign, or if you have three negative signs, if you have five negative signs, if you have seven negative signs, and then like dot, dot, dot. So like if you're multiplying a whole bunch of numbers and you have seven negatives total, then you know in the end your answer is going to be a negative result. So then you just right away put the negative there, and then you just start multiplying two at a time, multiply the numbers like their absolute values because you already took care of the sign. Okay, so that's what that means. Okay. And then the other thing I want to put on your paper, and I don't really have, I think I'm going to just squeeze this a thought here, is that if I were to, this is like an aside here, if I were to write a negative 1 all over 2, that's a negative 1/2. That is the same as this, a 1 over negative 2. So if you write the negative in the numerator, or you write the negative in the denominator, this is still saying that this is negative 1/2. It's negative 1/2. And also, if the student writes a negative, right, smack them in the middle, right, smack them in the middle of the fraction, that's also saying, all that's saying the same thing. This is negative 1/2, this is negative 1/2, this is negative 1/2. This is all quantity of negative 1/2. So when you type your answers in the computer, you do have that option. You do have the option. You can put the negative in the numerator or the denominator, or right smack them in the middle. So you do have that option, okay? Okay. Okay, then let's look at some problems. I want to start with the practice problems, starting with number 5 on page 43. So if you're still writing this down, you can pause the video and write it down and then just start it because it's a recording. Then just start it when you're ready. And we're going to look at page 43. Okay, so here's page 43. And so it says multiply, and then if you got results that are fractions, of course they want you to reduce your fractions to lowest terms, but that really goes without saying. They shouldn't have to say that. Students should know that fractions should always be presented in lowest terms, okay? Okay, so on number 5, 12 times 4, okay, and that's a times. They also could have written it like this. They also could have written like this, 12 times 4 with parentheses, okay? Or they also could have written like this, a lot of parentheses. That's really too much in my opinion, but they could have written it like that too. All that says 12 times 4. And that's just, if I just show you that here, long ways, 12 times 4, the number with the most digits goes on top. So 4 times 2 is 8, 4 times 1 is 4. So you see that's the 40, that's an answer of 48. Okay, so you didn't really need a sign. You didn't need this rule 4 sign rule for that. Okay, now on number 6, you're multiplying 3 numbers, okay? But notice how one of the numbers is a 0. And so that's going to take power over everything. The product of 0, any number times 0 is 0. So this is automatically going to just be 0 because of that. Any number times 0 is 0. And you don't have to show any work for that. That's a special case because it's the product of 0. And you didn't need to count your negatives. You know how I was talking about this rule? You're multiplying a whole bunch of numbers and you count your negatives. I mean, this is 2 negatives, right? Which is an even amount. But 0 is neutral, 0 is neither positive nor negative. And so you have 2 negatives, which is a positive. So you should have a positive result. If you had 3 negatives, it would be 3 negatives is odd, right? So it'd be a negative result. But if you have 0, anything times 0 is 0, and 0 is not you never write a negative 0. It's like considered neutral. Okay, just keep that in mind. Okay, on the next part, they want you to divide and reduce the fractions to the lowest terms, and then you might have to round answers with decimals to the nearest tenths, maybe if necessary. If it's really long, they want you to chop it off at the tenths place. Okay, if that's the case, if you have to round, this is the ones place value. Here's your decimal, which is the and then you have tenths, round to nearest tenths, and then you look at the neighbor. The neighbor is hundredths. So if they want you, if you get a long answer and you have to chop it off and terminate it at the tenths, you still need to look at the neighbor at the hundredths place. If this is 5 or more, then this gets increased by 1. But if this is not 5 or more, then this remains the same. Okay. All right. So and there may not be a need for that. They should say, round answer with decimals nearest tenths, if necessary. And I don't think it's going to be necessary on these 2 problems, but let's see. So on number 7, you have -20 divided by -10. So this is a negative divided by a negative. So this tells you have same signs produce positive results. So a negative divided by negative is a positive. Okay. And so this is going to be a positive result. And these n zeros can cancel out. If you have an n zero and an n zero on the top and the bottom, you're allowed to cancel those out, divide those out evenly. And then you really end up with -2 over -1. Well, really, I'm going to say you have 2 over 1, because we already said that a negative divided by negative is a positive. So we already know this is a positive, but you have 2 over 1. But never stop there. Never leave it as a number over 1. 2 over 1 is just 2. That's where you stop at. Okay. And so if I do the long division on that and use 20 divided by 10, 10 goes into 20 2 times. 10 times 2 is 20, and 20 minus 20 is 0. Okay. You don't want to set it up. This is wrong. So when students are learning, if students do this, if students do 10 divided by 20, that is wrong. That is not how you set up the long division. The top number, the numerator, goes inside the house. So the numerator, which is the top number, goes inside the house, the long division house. Okay. And it's not the same answer, because what if a student writes this, they've changed the problem. If a student is trying to set this problem up like this, what they're really setting up is this. This is really 10 divided by 20. See? And this can be reduced by 10. 10 divided by 10 is 1, and 20 divided by 10 is 2. So see, that's 1/2. See, but you've changed the problem. Now you're not handling this problem. Now you're handling this. And you see 2 is not the same as 1/2. It cannot, both students cannot be right. Okay. So this is, you don't want to do that. You want to learn how to set it up correctly. And then -5 and 6/10 divided by 7. Okay, so remember, you want to learn how to set it up correctly. And also, these are different signs. This is a negative number divided by a positive is going to equal to a negative. And that's because you have different signs. Different signs produce a negative result. Okay, so definitely, you want to definitely right away, put your negative there. Okay, and then when you set it up, the 5.6 goes inside the house. 5.6 divided by 7. And then you're going to pull your little decimal straight up. Okay, and then you're going to start dividing. How many 7s go into 5? Okay, well, think of shoe sizes. If you're a size 7 shoe, it would be very difficult. You wouldn't be able to squeeze that foot into a size 5 shoe. So I'm going to say 0. How many times is 7 going to 5? 0. Now, how many times is 7 going to 56? And that's about 8 times, because 8 times 7 is 56. So remember, technically this little decimal isn't there because technically you pulled it up. So technically this is like 56, and 8 times 7 is 56. 56 minus 56 is 0, and that's your remainder. So then you ended up having just negative 0.8. Okay. And so you didn't have to round off. It said be ready to round to nearest tenths if necessary, if it's really long. But it wasn't long at all. It stopped on its own on the 10th place. So you don't have to round. It took care of that itself. Okay. And then I think this problem I'm not going to do. These are applications. They want you to find the mean. There is one in your workbook that we're going to do that has more numbers. I think I'm going to do that one instead. But the mean is that you would, well, I guess I could do both, right? I'm doing a recording. Usually in class time, real class time, I'm pressed for time, but I guess I could actually do this one too, because we were doing a recording. So let's see, your mean is you're taking an average, you're adding them up and dividing by how many numbers you have. And this is, I have a little answer key there. So you see they're saying that's what the answer is what they're saying. So let's show your work. So I would recommend you put the X bar. We use that in statistics, and that's going to be the mean for a sample of numbers. And then you want to add up all the negatives separately and then add up all the positives. So if I add up all the negatives here on the side, let me do, let me see, -10 and -17 and a -34 and just barely enough room for -42. And I'm going to add all those up. Okay, so start adding those up. Use your fingers. Show your carrying. Okay, looks like that's going to give you a -103. Okay, and now you're going to add up all the positives. Let's see how many positives you have. So those are all the negatives. Now let's add up all the positives, which is 15, 16, and that's it. Okay, looks like that's a +31. And then we're gonna set up here. We're gonna divide by how many you have. 1, 2, 3, 4, 5, 6. Looks like you have 6 6 numbers, okay? And then this is using rule. Distance of 31. So 103 is bigger. So the negative beats that out. And then I'm gonna subtract. Let me do a subtraction right here. 103 take away 31. So 3 take away 1 is 2. And I'm gonna call this 10. 10 take away 3 is 7. So it looks like that's a negative 72. And then I'm gonna do negative 72 divided by 6. So you know it's gonna be a negative for sure. And I'm going to do 72 divided by 6. So 6 goes into 7 one time. 6 times 1 is 6. 7 minus 6 is 1. Okay, bring down the 2. And 6 goes into 12 twice. And the remainder is 0. Okay. So it looks like the answer is 12. The answer is 12. Okay. It's 31, so that gives you a negative 72. Okay. So you can go back and double check just to make sure you don't have an error. You're using a calculator as a tool, but you see how we want you to do it on paper by hand first. We need you to be practicing that, and the calculator just as a tool. Double check that. Okay, now let's look at page 46. See. So number 1, we have -2 times -5. Okay, so that's going to just give you 10. And there's no work for that. Same signs, right? These are same signs. Same signs give you positive results. Number 2, 4 and 8/10 times -8. Okay, well, that's going to definitely be a negative something. Different signs produce negative results. So different signs are going to give you negative results. Okay, but negative what? So let's set this up. 4.8 times 8. The number with the most digits goes at the top. 8 times 8 is 64. Carry the 6. 8 times 4 is 32. And then you're carrying 6. Looks like that's going to be 38. Okay, so it looks like it's going to be, oh, and then you count your decimal moves. You have 1 decimal move right here. The 8 doesn't have a decimal move because the decimal technically is behind the 8. So there's just 1 decimal move, and you move that from right to left is how you move that. And that's just 1 decimal move. -38 and 4/10. -38 and 4/10. Okay. And then on number 3, you have -3 times -4 times -5. Okay. So one thing you can do is, because you're multiplying a lot of numbers, you can count your negatives right off the bat. 1 negative, 2 negative, 3 negatives. So you have an odd amount of negatives. which is 3 negatives. So that means the result, according to our rule, is going to be negative. So I know you remember we wrote that down. We wrote that down here. So if you have an odd amount of negatives, their product's going to be negative. So that's what we have: 3, 1, negative 2, negative 3, negative. That's an odd amount. So you know for sure this is going to be a negative something. Okay. Then you can just work now with the absolute values of the numbers, because you already know you took care of your sign right away. So now you can start doing, okay, 3 times 4 is 12. And then you can do 12 times 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5 plus 1 is 6. So now you know that's negative 60. So that's one way you can do that using this rule. Or if you don't want to do that, if you do that as a spot check that your answer should be negative when you're done, the other thing you can do is just say, okay, take them two at a time, like from left to right. So you can do -3 times -4. And that says same signs produce positive results. Remember, same signs produce positive results. So that gives you a 12. And so you put a little check mark that you already got those done. And now you need to take that 12 and now you need to multiply it with this one, -5. And now you have different signs. See right here? Different signs produce negative results. So see, that should give you a negative. 5 times 2 is 10, carry the 1. 5 times 1 is 5 plus 1 is 6, and then you have a little negative. So you see that gives you a -60. Okay, so think of that as 2 ways of showing your work. Okay, so this if you want, you can think of this as a little double check. Like, okay, I'm gonna double check my work. If I have odd, like I got -60 doing it this way. So what did the rules say? Yeah, if you have 3 negatives, that's an odd amount. It should be negative. So it's like a little double check for you also. Okay, now on number 4, notice how, and again, this is on page 46. Remember, this is the same page 46 that we're working on. Notice how you're multiplying two fractions, 4 9s times a -7/24. The easiest way to teach multiplying fractions is to tell you this, that to multiply fractions, just multiply straight across, which means this way, straight across. So notice your teacher didn't say cross products. I didn't say cross products. I did not say to do cross products. This was cross products where you do this. Cross products. I didn't say to do cross product. I said multiply straight across. Okay, so that means literally this way, straight across. Okay, and so if we do that, there's another step, but let me put a little bullet here, and I'll put a bullet there for the idea. So if I start with that, 4 times -7, that's a -28. And then 9 times 24. And I can use my multiplication chart or my calculator. Usually the rule of thumb is, because we provided you with a 30 by 30, and we also provided you with a 12 by 12, right? You also have a 12 by 12 multiplication chart. Usually the rule of thumb is that if you can use your 30 by 30 chart, if you can find on your 30 by 30 chart, you don't have to actually write it out unless you've got like decimals involved or something. But like this one, 9 times 24, 9, and I like to use my ruler. 9 times 24. So here's 24. It looks like it's 216. Looks like it's 216. Okay. And then of course, you could use your calculator too, because technically that is on your chart, right? It's on your 30 by 30 chart. So I double check 9 times 24 is 216. Okay. Okay. But then the next thing to do is then you want to reduce to lowest terms if possible. Not everything is reducible. So you want to reduce to lowest terms, and you want to identify either the common divisor, which I'll call CD, or the greatest common divisor. Okay, so you want to communicate that with your teacher, and that's where I show this here. Okay, so sometimes it's kind of hard to spy out the greatest common divisor, to spot that. Sometimes it's, you need to do it in chunks, and then you're just going to find or spy out a common divisor. So I'll start with that first, a common divisor. What I see right away when I look at these numbers, 28 and 216, I look at the 8 and the 6. Those are even numbers. Let me highlight the 8 and the 6. And if you're wondering, well, how does she know that fast that those are even numbers? It's because even numbers in a 0, a 2, a 4, a 6, or 8. So I already know that from memory. So when I see 8, it ends in 8. I see this ends in 6. I know those are even numbers because they end, see, in a 6 and an 8. So they end in these numbers are even. And then we also know that even numbers are reducible by 2. Yeah, so we know that 2 will go into even numbers. So that's a sure thing. Feel comfortable with that. So that's why I can say I can start with 2. So if I communicate that to my teacher, and then I start dividing, I'm going to start with negative 28 divided by 2. So you're just cutting that in half. Half of negative 28 is a negative 14. And then half of 216, 216 divided by 2 is 108. Okay. And then if I reduce again by 2, negative 14 divided by 2, because again, these are even. See, the 4 and the 8, those are even numbers. So I know I'm safe with 2. So that gives me negative 7. And then 108 divided by 2 is 54. Okay. And then I'm pretty sure that's lowest terms. I don't think anything else would go into 7 and 54. If I try 7, let's see, negative 7 over 54. If I try 7, the first part, I'm okay. I don't get decimals. If I do negative 7 divided by 7, that's okay. I get negative 1. But the issue is on the bottom, 54 divided by 7. See, I get a decimal, 7.714 and dot, dot, dot. That you cannot do. You cannot have decimals like that in your fraction. Okay. So I'm pretty sure that's lowest terms. And this is called a proper fraction. Let's call a proper fraction. Okay. Not improper, but proper. See, if I just look at the 7, I know it's a -7, but if I just look at the 7 is, smaller than the 54, that's proper. If I had gotten something bigger, like 56 or 58 on top, something bigger, that's called improper, okay? And then now that we've done that, now what you can do is those were common. This was a common divisor. This was a common divisor. But now that you've done that, let me say that 2 times 2 is 4. That would have been the greatest common divisor. So I could have started with -28 over 216, and then I could have done divided by 4. That would have been the greatest common divisor, and you would have gotten there a little bit faster. Okay. -28 divided by 4 is -7. And 216 divided by 4 is 54. See how you get the same answer, but a little bit faster. But that's a little bit harder for people to see. Sometimes it's hard to see what the greatest common divisor is. Sometimes it might be the smaller of the two. Sometimes if you look at your fraction, and sometimes the smaller of the two, it might be that also. In this case, that wasn't going to happen here. When I do -28 divided by 28, yes, that gives me -1. But when I do 216 divided by the 28, see, I get a decimal. Yeah, decimal. So yeah, that cannot happen on that. So that's your result for that. Okay. Now, one thing I also want to stress is notice how I did not use a list of multiples. Notice how I did not just multiply the, well, I should say this. Notice how I didn't try and find a common denominator and build up the fractions. When you're multiplying fractions, this is what you do. You basically multiply straight across, and then you try to reduce. You do not find a LCD or an LCM. So do not find a LCD, LCM. Okay. Don't build up the fractions. Don't build up the fractions. Don't build up the fractions. Okay. All right. Okay. So we only do this work if we're adding and subtracting fractions. So this work is for adding or subtracting fractions. That work is for adding or subtracting fractions, not for multiplying them. Okay. And so it's really tough when I'm grading papers. It's a shame because, that takes a lot of time. Sometimes I have students that they do find a common denominator correctly and they build it up, but all that work is done in vain because if they're not going to get the right answer because they're multiplying them, and you don't do that kind of work for multiplying them. It's only for adding and subtracting. So I'm sorry, I cannot mark that correct. It's not correct, but it's a shame because that's very time consuming to do all that work. And your tests are timed. You don't want to be doing all that work and then it's all in vain. You don't even need it. So you want to be alert, eagle's eye, and know when to do this and when not to. So you don't do it for that. Okay. Okay. Okay, next we're going to page 47. And I think this is the last page. This is the last page of 8.4, I believe. Okay, so let's look at number 5. 5/3 divided by -3/10. Okay, notice here how you're dividing a fraction. So when you divide a fraction, we're going to show you one step and you're going to make it into a multiplication fraction. And then after you make it into a multiplication fraction, then I'll just rewrite these two steps and then you just follow these steps because you're multiplying fraction. But the very first important thing to do is, we put A here, is you want to, let me say, to divide fractions. To divide fractions, you want to multiply by the reciprocal. So to divide fractions, you want to multiply by the reciprocal. And so you might be saying, what does she mean by reciprocal? Okay, so to divide fractions, you want to multiply by the reciprocal of the second fraction only. Because sometimes people say, do you do the reciprocal on the first one too? On both of them? It's only on the second one, only on the second one. So I'm going to highlight the second one. And then some of you are going to be saying, okay, what does she mean by reciprocal? What is that? So all reciprocal means is you just flip the second fraction. Or if you don't like the word flip, invert. You just invert the second fraction. Okay. So let me demonstrate that here. So you have 5/3 and then times, you're going to multiply times, and then you're going to flip this. Now, this is still negative. So I'm going to leave the negative here. It's still negative. But then the 3/10, I'm going to flip the 3/10 and make it 10/3. Okay. And so that was why earlier in my lecture, let me find that paper. That was why earlier in my lecture, I was saying that this idea here that if I have, see, -1/2, this is -1/2, this is -1/2, this is all -1/2. But sometimes you can put the negative on the top or the negative on the bottom or the negative right smack them in the middle. Okay. Well, this is a -3/10. And we just said to, take the reciprocal. Did I use the word opposite? Did I use the word additive inverse? Because y'all learned that in the previous section. I think 8.3, you learned that previously. Those words opposite and additive inverse mean take the opposite sign. We don't, sometimes students try to take the opposite sign and make it a positive, but we didn't say that. I didn't say to do that here. I didn't say that here. I didn't say take the opposite or do the additive inverse. I said you just multiply by the reciprocal. Reciprocal means you just invert the fraction and you just flip it. So it's still going to be negative. We did not tell you to change the sign, make it opposite sign. We didn't say that. We just said you flip it. So it's still going to be negative, but then the 3/10 becomes 10/3. Okay. Now, if I had, let me show you another little example. We're not done with this, but let me just show you this. If I had, I was just making this up off the top of my head, right, in class. If I had a -1/8 divided by 2/3, if I had that, okay, and then this is the negative. Again, you want to multiply by the reciprocal of the second fraction. So this would be -1/8. And then the division would change into times. And then you want to flip. There'll be 3/2. Okay. So this is, I'm going to highlight the 2/3. And you see, your teacher just flipped it. I just inverted it, made it 3/2. And it's still going to be positive. It's still positive. Okay. Just like this was still negative. I just flipped it. This is still positive. And then also, if I have 3/4 divided by 7 nines, okay? And then this is still want to multiply by the reciprocal of the second fraction. So I'm going to highlight the 7 nines. So this would be 3/4 times 9 sevens. Okay. All right. Okay, so we'll go back and finish those, but that's I want to stress that's what we mean by to divide fractions, you've got to multiply by the reciprocal, okay? Okay, but then the next step will become the steps, because now you don't look at this anymore. You don't look at this anymore. Now you look at these, right? Now you look at those, and now you're multiplying fractions, see? Multiplying fractions. So the easiest way to explain to multiply fractions is to tell the students to multiply fractions, just multiply straight across, okay? And then reduce to lowest terms if possible. So let me write that down. So to multiply fractions, multiply straight across. Okay, I didn't say cross products. I didn't say cross products. And then reduce to lowest terms if possible. Or simplify. Sometimes you can simplify things. You might be saying, what does she mean by simplify? So here's an example of simplify. Let's say you ended up with 6/3. 6/3 is just 2. So that's what I mean by simplify, okay? Or you might have to reduce. And when we were reducing, this was reducing. Like over here, when I had -28/216, I reduced it by 2, and I reduced it by 2 again. I got -7/54. Or I reduced -28/216 a little bit faster just by reducing right away by 4. That's called reducing. So you might have to reduce, or you might have to simplify. If you get something like 6 divided by 3, that's just 2. That's simplifying. Okay. All right. Okay. So now let's go ahead and do that on number 5. Let's go to this. Let's multiply straight across. 5 times -10 is -50. 3 times 3 is 9. Okay, and I think that's lowest terms. I don't think like 2 can't go into it because these are not both even numbers. This one's even, but this isn't. When you reduce by a common factor, it's just like you cannot use different numbers on top and the bottom. Like you can't say, oh, I'm going to reduce. You cannot do this. Oh, I'm going to reduce this by 2, but I'm going to reduce this by 3. You cannot do that. When you reduce, you cannot do that. When you reduce, you have to, it has to be a common number, a common factor, a common denominator you're reducing for the top and the bottom. They share that. So you cannot do this business. That's wrong. So yeah, so you don't want to get decimals for that when you're trying to reduce. So yeah, 2 won't work and 3 won't work, because 3 will work on the bottom. 9 divided by 3 is 3, but 3 doesn't go into 50 evenly. If I look at -50 divided by 3, you see how you get a decimal. Yeah, so this cannot be reduced anymore. But so I'm going to box that, but I'm going to say that is called improper. That's an improper fraction. And if I just look at the 50, see how the 50 is bigger than 9? That's what makes it improper. So sometimes the book will say, we might want you to make numbers into mixed numbers, but they have to tell you, we want you to make this into a mixed number. And improper fractions are made into mixed numbers. Mixed numbers look like this. mixed numbers look like that, okay? And they call for long division. Okay, so this is going to be a negative something. Negative 50 divided by 9. Different signs produce negative results. But now if I do long division, you have to know that the numerator goes inside the house, 50 divided by 9. And it turns out that 9 times 5 is 45. 9 times 5 is 45. So 9 doesn't go into 5, right? It's 0. But 9 goes into 55 times because that's 45. And then 50 minus 45 is 5. Okay. So right here, the mixed number, instead of writing 0, 5, right here, you put 5. So I'm going to put a 5 here. Okay. So then now sometimes they want decimals and they want you to round to the tens, round to the hundreds. Then that means you would, then that means this, you know, you would add a decimal, pull it up, have a 0, pull it down, right? If you want to round to a tens or the hundreds, you want decimal, but they didn't say anything about that. And what we're trying to do is make a mixed number. So this, you don't do that here. You don't do that here. So your remainder then is just 5. That's your remainder. That's your R for remainder. R for remainder of 5. That's a remainder of 5. Okay. And this gets written like this, like clockwise, like that. So next, you already wrote down this 5 here. So next is this. So now this becomes your R. Your remainder is 5. That goes here. And then it goes clockwise. So last you have 9. 9 goes here. So see, that doesn't change. See, your 9 is here. Your denominator usually doesn't change. So that's negative 5 and 5 nines. Okay. So what happens is this is called the quotient. The quotient becomes the whole number. The R, the remainder becomes a numerator. The remainder becomes a numerator. And then the 9 is your divisor. The 9 is your divisor. So the divisor, which is 9, becomes the denominator. Becomes a denominator, okay, which stays the same, because see, your denominator here was 9 and it remains. It remains. So I would say it remains 9 and 9 kind of remains. Okay, you could think of it that way. All right. Okay, now let me go back to these extra columns I created and finish those. Right here, let's finish this one. Negative 1/8 times 3/2. So multiply straight across. Negative 1 times 3 is negative 3. 8 times 2 is 16. Okay, and that cannot be reduced. That's lowest terms. You cannot reduce by 2 because they both have to be even numbers, and 3 is not. You cannot reduce by 3 because 16 divided by 3 gives you a decimal, and you want to stay away from those. See, when you're trying to reduce. Yeah, so that's lowest terms, and that's called a proper fraction. Let's call a proper fraction, where negative 50, the 50 is bigger than the 9, 50 is bigger than 9, that's called improper. When the 3 is smaller than 16, just looking at the 3 is smaller than 16, that's called proper fraction. And you cannot make proper fractions into mixed numbers. Let me write that down here. Note, proper fractions cannot be made into mixed numbers. Okay. You can only improper fractions can be made to mixed numbers because they're like mixed numbers. See, mixed number, the way it's set up, it's got to be like over one, this I know is a negative, but like 1 and 1/9, or like this is 5 and 5/9, or -5 and 5/9. This, you got to have it's got to be a value of, I guess you want like 1 and something, 2 and something, 3 and something for a mixed number. And that can happen with 3 divided by 16, because even if you look at on the decimal side, decimal 3 divided by 16, see how that's a 0 point something. There's got to be at least one. A mixed number's got to have a whole number here, 1, 2, or 3. Even if it's a -1, -2, it's got to have some kind of a whole number here, and it's got a 0. So yeah, proper fractions cannot be made into mixed numbers. And then if I finish this other problem here, I made this one up, multiply it straight across. 9 times 3, or 3 times 9 is 27. 4 times 7 is 28. And that's lowest terms. And that's also proper or improper. It's proper. And it's almost 1. 27 divided by 28. If you had 28 over 28, 28 over 28 would have been 1. You're real close to 1, see? 0.96 something. You're real close to 1, okay? All right, okay. And then just stay alert. You're dividing fractions, so let me make a note here. Do not find LCDs or LCMs. Do not find LCDs or LCMs when multiplying or dividing fractions. Okay, don't do that. And you can't stress that enough. You only try and find a common denominator and build up your fractions only if you're adding them or subtracting them. And you see you have a division sign right here. So don't do that. Don't do that for problem number 4. Don't do that for problems like number 5. So you got to remember that on the test, okay? Okay, and then on number 6, 70 and 2/10 divided by -7 and 8/10, okay? And so remember how to set this up with long division. Remember the top number, the numerator goes inside the house. And I know that's a negative. This is different signs produce negative results. Let me just put the negative right here. Okay, and then let me just say I'm dividing that by 7.8. Okay. Okay, now remember what we said about this is a divisor. Divisors need to be counting numbers. And counting numbers are like 1, 2, 3, and so on and so on. See, and that's a decimal. You cannot have 0 there. Remember, if it's 0, it's undefined. And you cannot have decimals. So what we do is we scoot the decimal over. See here, I scoot the decimal over just 1 decimal move. And now that grows to 78. That's a counting number. It's a big counting number, and that's fine. You got your ellipses. But what you do to the inside, you also do the outside. So this is 702. And then now you're going to start dividing. Now here I would use your calculator as an aid because your multiplication chart only goes up to a 30 by 30. And you see you don't have a multiplication chart for 78. So here we will use our calculator to help us build this up, and then we'll show our steps. So I do, you want to do 702 divided by 78. So you're expected to show this work And then here you can use your calculator. And oh, this is nice. It goes into it nicely, exactly 9 times, exactly 9 times. Okay. And 78 times 9, 78 times 9 is 702. So you know how you multiply this times this? So 78 times 9 is 702. So you want to finish that off. Don't leave it hanging there. And the remainder, the R for remainder is 0. So don't forget right here, don't forget it's a negative. It's like sometimes students will put a 9 in the computer. Don't forget it's a -9. Okay, and then the last problem is a mean. So we saw the mean earlier on this previous problem, number 9. So we saw a mean with fewer numbers over here. And we got a -12. Okay, I didn't do every single problem. So like I didn't do this problem, but the answer for that looks like it's 100 thousands million. That's a big answer. Hundreds, thousands, millions, 15 million, 200,000. So I don't always do every single problem, but if you want to do that on your own and you see if you get that result, and then if not, you can communicate with me through a Canvas inbox email if you're curious about that. On page 43. And then on these, I'll share these with you. You can put the answers 43, because I don't think y'all have the answers to these. So I'll review the answers and then you can go back over those and review them. And if you have a question, you can send me a Canvas inbox email for that. But on page 43, 1 should be T for true. 2 is T, so put a little T by that. 3 is F for false. And then 4 is F for false. Okay, so then you can pause the video, like if you want to take the time to write this out, you can do that and then review it later afterwards. And then if you have a question about it, you can email me, send me an email, Canvas email about that. But other than that, I'm going to pause it and write that down. Okay, but I was just referring to it because of number 9. It's a mean. So that's what we're going to do here on 7. On 7, if we find the mean, and we might have to round, if it's really, really long, we might have to round to nearest tenths. So if they want you to round to nearest tenths, if we have to, you have to look at the neighbor to the hundredths place value. And if this is 5 or more, then you add 1 to whatever is here. But we may not have to round. So let's just see. Let's just say round if possible, if needed, if needed. So here, let's add up all the positives and all the negatives. So let's see, on the positives, let me stack them way up here. So I have 27, 29, 21, and I'm gonna do this on this side, -9, -6. Okay, this is 2, 15, 6, 6, 9, 2. Okay, this is -8, 18, -7, -5, okay, 21. This is -3, 30, 16, and 22. Okay. So remember in this class, we want you to be mentally practicing this, right? So yeah, you can use your calculator to double check your answer, but really you should practice your arithmetic and add those all up, and then double check that. So what I'd like you to do now is like right this point, if you're going to participate, right, with this activity, go ahead and like stop the video right now, stop it, and then go ahead and add those up, and then add those up. And then when you're done, then turn it back on, and then you're going to see me working it out. Okay, so go ahead and pause it. Okay, All right, Kai. So I'm assuming that you did pause it and you took some time to work it out, and now we're going to double check. So, so if we do this, let's see. And I'm sorry, I should have my answer out right away to double check. Okay, let's see. So, okay, what I have for all the negatives here is you should have, when you added all these up, that should have given you a negative 38 for that. And this one, when you added this all up, that should have given you a 224. So let me see what you had to carry. What did you have to carry up here? I don't have it noted here. Let me see. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hmm. I think you had to have added a 5. I think was what happened. 16, 17, 18, 19, 16, 17, 18, 19, 21, 22. No, I think you had to have added a 6 there. So let me do 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yeah, I think you had to add, carried a 6. So I think it was 64, you carried a 6, and then that would have given you 222. And the reason why I say that is because on my notes here, I have a 224, and this is degrees. These are degrees. These are degrees. So we put a degree here and here, a degree on the first one, and a degree there. I have 224 plus 38, negative 38 degrees is what I have on my paper. And I'll use parentheses. And I'm going to divide it by 20 because C said it was 20 days. And that looks like it's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10 columns, and then times 2 rows, that would be 20. Didn't make a mistake and leave any numbers out. Okay. And then this is using rule number 2. You're adding 2 numbers with different signs, and this positive sign beats out. Positive sign is bigger than this negative, the bigger absolute value. So it's going to be a positive something divided by 20. So I'm going to subtract, right? You subtract the numbers 224 minus 38. So I'm going to make this a 14. Decrease this 2 and make it a 1. Okay, 14 minus 8, so it means my fingers 8, 9, 10, 11, 12, 13, 14. So it looks like a remainder of 6. And then I can't do 1 take away 3, but I can make it an 11 and then decrease the 2, make it a 1. 11 minus 3, so it looks like it's 8, 9, 10, 11, and then 1. Okay, so it looks like that's going to give you 186. So it's 186 degrees, and it's positive because 224 is bigger. This one was the larger absolute value is positive. And now you're going to do 186 divided by 20. So let me see. It's degrees. Let's see. 186 divided by 20. Okay. So 20 doesn't go into 18, doesn't go into 1. It doesn't go into 18, but into 20. Let's say I'm going to use my multiplication chart. I want to get as close as I can. Look at 20. Okay, as close as I can to 186. There it is, 180, because then that's 200, it's too big. So 180. So if I go up to the top, this times 9 times 9. Okay, times 9. So 20 times 9 is 180. Then I'm going to subtract. And then when I subtract, 6 take away 0 is 6. 18 take away 18 is just 0. So it's a remainder 6. But they want you to round to nearest tens. So they don't want like a 9. They don't want this. They don't want like, they don't want 9 and 6/20 degrees, because that looks awkward, right? In degrees and temperature. Have you ever seen a temperature reading like in a fraction? No, right? That looks odd. That hurts my eyes, right? So they want you to round to nearest tens. So that means then that this is where I'm going to have, instead of stopping at the R, this is where I add the decimal and I pull it up and I add a 0 and I pull this down. And now I have 60. And how many 20s go into 60? 3. 20 times 3 is 60. And 60 minus 60 is 0. So that gives you 9.3 degrees. Okay. 9.3 degrees. All right. And that's a wrap. That's a wrap. Okay. So I hope that helps with your review of your recording. Okay. And good luck with your homework then. Okay. Mine on math.